smaller in size than silicon. So it will be a what type of a impurities that will be. Okay, so someone said it is C, interstitial impurity. Yes, that's the correct answer. It will be an interstitial impurity. And if you guys need like more explanation, like why is it like that, this is the time we discuss about it. So just let me know if you have any question, any concern, like why is it like this, or maybe there might be I can give you, maybe your understanding is different or your approach might be different, so we can talk about it now. Shortkey defect in ceramic material is, and you can say it actually, you don't need to, not necessarily you need to type it. If you do not have any issues with your microphone and all, you can just say it here. Shortkey defect in ceramic material is it interstitial impurity? Was that
C?
It is C, the pair of nearby cation and anion vacancies. Yes, in a Shortkey defect, a cation and anion, to maintain the stoichiometry and to maintain the charge, they both are missing, creating a vacancy. So it is known as a pair of nearby cation and anion vacancies. Right answer is C. Which one of the following is not a strong bond? Is it van der Waals bond, covalent bond, metallic bond, or ionic bond? Anyone? Once again,
A.
A. Okay, good. Yes, A is van der Waals bond is a weak bond among all these other bonds. Okay, which one of the following is not a point defect? Interstitial atom, substitutional atom, edge dislocation, none of these are point defects. Which one of the following is not a point defect?
That'd be
Yeah,
C.
dislocation. Yeah.
That will be C, edge dislocation. Edge dislocation is a one-dimensional defect or a linear defect. Okay, it's on the other hand, the interstitial atom and substitutional atom, they both are point defects. The first and second shells of an atom are full. Its atomic number is
10.
10. Yes, because the first shell configuration will be 1s2, second shell 2s2 and 2p6. So 1s2, 2s2, 2p6, total 10 electrons. Atomic number is 10. A neutral atom with the atomic number greater than 1 consists of
Proton, neutron, and electron.
Electron. The right answer is D. Okay, I think most of these questions, they came straight away from the concept test or the in-class problems that we cover at the end of every chapter. But once again, I'm telling you that in-class problems or those concept test problems we do to reinforce our understanding, and sometimes I include new concepts in those problems. But you don't expect that for for the next exam and the final exam, those questions will come as such. Okay, I have to increase because it looks like the grading. I think the students they did well in the test. So I have to match what to say, the difficulty level with the class. How you guys are approaching towards these problems. So I had to match with the difficulty level. Okay, so if the class is not doing good, so I match it accordingly. But you guys are doing good. We need to raise the bar or our standard higher. So so the next test or next assignments will be a little bit more complicated. Okay. Imperfection. Next question. Imperfection most likely to be present in a single crystal alloy include all of the following except for. In a single crystal, which type of imperfection or defect will be there except for
Grain boundary.
grain boundaries? Yes, because it is made up of a single crystal, right? So single crystal will not have any grain boundaries. Large amount of undercooling does not occur during industrial casting operations because because impurities lower surface energy, nucleation occurs at lower undercooling. Was that?
D.
It's D, all of the above?
Yes, sir.
Yes, because large amount of undercooling, because it's not, see, industries, they don't, they favor heterogeneous nucleation method because of this following, advantages. They add impurities that can lower the surface energy. They provide a solid surface, and so that the nucleation will occur or will start even at a lower undercooling value. So it will start early, it will start sooner to finish the crystallization process.
I have a question for that one.
Say that again.
I said I have a question for that one.
Yeah, yes.
Could you explain how the impurity lowers the surface energy in heterogeneous nucleation?
Okay, yeah, it's a good question. See, these impurity atoms, they are providing a solid substrate. You agree with me?
Yep.
Right?
Yes, sir.
So that means what? That as soon as the atoms which are in a higher energy state, because it's in a molten state, right? We are crystallizing from its molten state. So the atoms or the molecules, whatever it is, they are in a higher energy state because it's in a molten state, right? So they are highly excited, they're highly energized, they are in a higher energy state. However, as soon as they touches a solid surface, which is already in a solid state, okay. So solid state means what? It is a more stable state than a gaseous or a liquid state, right? So as soon as it touches the solid surface, they will start to crystallize right there. They will start to nucleate right there. So the impurities, they will lower the surface energy uh, for these atoms to nucleate or to crystallize.
Okay, thank you.
Does that make sense?
Yep.
Okay. What is or what are the advantages of Czochralski method?
B.
Is it B, growth of the large oriented single crystals? Yes, this is the advantage of this method, to prepare the single crystal of silicon so that we can get a large oriented single crystal. Which of the following is a point defect in crystals? Is it, we're talking about point defect. Is it edge dislocation, interstitial C, grain boundaries, cracks? Anyone?
Interstitial C.
Interstitial C is a point defect in crystals. Right. External surface is in higher energy state because coordination number of surface atoms not satisfied, extensive compressive strain on surface atoms, grain boundaries, or dislocations.
Would be A.
A.
It's A. Coordination number is not satisfied. That's why the external surface or a free surface or just the surface is in a higher energy state. Which one of the following is related with the twin boundary? Is it the mirror image of atomic placement across the boundary? Similar crystal structure of metals forming the twinned alloy, untwinned when heated. Twinning decreases the strength.
The A.
A.
It will be A. Mirror image. Twin boundary is a mirror image of atomic placement across the boundary. Because atomic mobility is higher at higher temperature, point defects can migrate and can form 3D defects. Is it true? Is it false? Or either of the above, or point defects are 3D defects?
True.
It's a true statement, because at high temperature, these point defects, they can move, they can migrate, and they can condensate to form 3D defects. For example, vacancies, they can migrate at higher temperature, and then they condense in such a way that they become a larger vacancy, which can be considered as a pore, and which is a three-dimensional defect. Which of the following is the correct statement? Impurities lower surface energy, nucleation occurs at lower undercooling, solid surface provides nucleating surface, all of the above. It's very obvious that it is D, all of the above, because it is kind of related with the previous question with the heterogeneous nucleation. Which of the following is a correct statement? Aqueous grains are found adjacent to cold mold wall. Grain boundaries have a higher atomic density. Ethanol is free of surface defects. Etchants remove tiny grooves along the grain boundaries.
A.
It's A. Yes. Definitely A, but what about D?
They have
Etch-
lower atomic
etchants.
densities.
What was that?
Don't grain boundaries have lower atomic densities?
No, no. What about D?
The etchants create tiny grooves along the grain boundaries. They don't remove them.
Etchants create the tiny groove, right? They don't remove tiny grooves, right? Because see the grain boundaries. Yeah, I remember actually this. See the grain boundaries. They are in a higher energy state. So what they will do is they will kind of attract sometimes some atoms towards them. Okay. So those atoms will be definitely just like the grain boundaries. They will be in a little bit higher energy state, and so along the grain boundaries, if there are some tiny atoms or a cluster of atoms is there, then they will also be removed along with the grain boundaries during etching process. Okay, so uh, these these cluster of atoms that have been removed, they will look like tiny grooves um, when we look at under the microscope. So this is not a correct statement actually. So that's why it is A. Okay, sea of electron means all the electrons in the metal, the electrons in the outer shell of that metal, electrons in the inner shell of that metal, or any electrons other than valency electrons.
B.
Electrons in the
It's B, because it is the outer shell or the valency electrons, they get removed from the metal atom, and then they become a part of the electron sea, the sea of electrons in the metals. Hydrogen bonding occurs in molecules when
C.
it will be C. A hydrogen atom bonded to small electronegative atom is attracted by an electron pair. Okay. Yes, right answer is C. How do atoms achieve noble gas electron configuration in single covalent bonds?
C.
It is C. Two atoms share two electrons. Yes, two atoms share two electrons or one electron pair. Right answer is C. Why is hydrogen bonding only possible with hydrogen?
A.
It's A. Hydrogen's nucleus is electron deficient when it bonds with an electronegative atom. Yes, that's a correct statement, because hydrogen has only one electron, and if that electron is attracted towards the electronegative atom, then hydrogen nucleus becomes electron deficient. Critical size of the nucleus during solidification of metals is expected to affect the following properties. Oops. Oh, okay, I could not see that arrow because of this screen. Yes, right answer here is D. I think it's a kind of a previous question only. Which one of the following is not related with grain boundary? Is it the higher energy state, highly reactive, location of atomic mismatch, or higher atomic density?
Higher atomic density.
B.
Higher atomic density, because grain boundaries are actually sites for lower atomic density. Why do ionic compounds have high melting and boiling point?
Strong bonds between the ions.
Strong, yes, there are strong bonds between the ions. In ionic compounds, we have cations and anions. These are oppositely charged ions. They will be strongly bonded with each other to have higher melting and boiling point. In what physical state or states do ionic substances conduct electricity?
That'd be B.
It will be B, liquid or dissolved in water. Yes, ionic compounds, when they are dissolved in water, then definitely the water will break the bonding, the ionic bonding, they become soluble, they get dissolved, and there's free ions, they will conduct the electricity. At the same time, if they are melted, if they are in a molten state, then that time also they conduct electricity because the ions, they can move freely. Why are metals good conductors of electricity? They contain ions that are free to move, they contain atoms that are free to move, they contain electrons that are free to move, or all of the above.
They contain electrons that are free to move.
They contain electrons that are free to move. Right answer is C. What is the combination of one or more metals with a non-metallic element? Is it a metalloid? Is it a matrix composite, inert, ceramics? What is that?
D.
Oh, B, matrix composite?
The ceramics.
Ceramics, yes, ceramics.
D.
Ceramics, D, they are actually made up of metal and non-metals, just like alumina. Okay,
Does
calcium
ceramics
oxide. What's that?
I have a question about this one.
Yeah, yeah.
Do ceramics have to have a metal in them?
Yeah, yeah,
Okay.
yeah.
Gotcha.
Silicon carbide, silicon metal, carbon non-metal, alumina, aluminum metal, oxygen non-metal, silicate like SiO2, which is a glass. So silicon metal, oxygen non-metal. So they have to have a metal and a non-metal. Okay, so we are done with the quiz. So we'll start with the test. Okay, your first exam.
Hey, on Professor.
Oh, yes.
I haven't taken the exam yet. Since it's my day 3 schedule.
What's your name?
Justin.
Justin. Did you email me about when do you want to take?
Yes, I emailed you some dates yesterday, and I did it again just at the beginning of class.
Right. So I'm waiting for a reply for one more student, and then I cannot conduct at a different time because it will be just another test. So I cannot make a different test for each and every student, right? So
Right.
I'm waiting for one more student, and then most likely you all three will be taking at the same time. Okay,
Yes.
but I will let you know.
Okay.
Okay. Yeah. Write and explain 3 differences between Schottky and Frenkel defect under the heading effect on density. What is the effect of Schottky defect and Frenkel defect on density? Does any of these defect affect the density, or which one?
I know the Schottky doesn't affect
Schottky doesn't or does?
Schottky does.
Schottky does, because
Oh yeah.
in a Schottky defect, your cation and anion both are missing, right? So both are missing. They're missing completely. So that means your material is missing, right? So it will definitely decrease the density. However, in a Frenkel defect, your cation is missing, but it is not completely vanished. It is there in the interstitial location, which is nearby, right? So your mass balance is there. Actually, material is not missing. So mass is not missing. So Frenkel defect doesn't affect the density, but the Schottky defect will decrease the density. Okay. Effect on electrical conductivity. See, electrical conductivity means what? The movement of the ions, right? In this case, right? Whether it will be the movement of electrons or the movement of the ions. So whenever these during the Schottky defect, your cation and ion, they both are missing. So wherever wherever they were there initially and now they are missing, that's like an empty that's like a gap. It is considered as a hole. Okay, so in that hole, another ion can that hole or gap can be accommodated by another ion. So another ion will that hole or a gap will be replaced by another ion, and then that ion, wherever it has came from, might have created another gap or a hole. So like that, these holes and these ions, they move. Okay, and then they move, and that will conduct the electricity. So Frankel defect can also have conductivity. The both can be conducting. However, the Schottky defect, if there is an extensive Schottky defect in a crystal, that might that will have a higher conductivity. Okay, effect on stability of the crystal. What do you think? Which defect will destabilize the crystal? Anyone? Any what to say? Because these type of questions, they definitely, evaluate your critical understanding. You need to think very, very critically. You know what's going on in this, right? You know in a Schottky defect what's going on, what is missing, what is the extent of missing, what is going on in the Frankel defect. You know all those things, but you have to just think very critically. Will there be any effect on the stability of the crystal, or will there be no effect? Or if there is an effect from either one, what will be the effect? Yeah, what do you think?
Would Frankel decrease the electrical conductivity? Or
Well, it will not decrease the electrical conductivity. It will have less electrical conductivity than Schottky defect. They will not decrease the electrical conductivity. In fact, they will impart some conductivity in these ionic compounds, because wherever any ion is missing, that is creating a hole. Okay, and that hole might be replaced by another ion from a different location. So that another ion, wherever it has came from, there also another hole will be created, right? So these holes and the ions, they will start migrating, right? So once they migrate, that is the electronic conduction. So they both will be conducting. However, the Schottky will be more conducting. Okay, so similarly, see, we're talking about the effect on stability, right? So the Schottky defect will create numerous holes in the crystal. That's what the Schottky defect is, right? So the cation and anion, they both are missing. It will create a lot of holes in the crystal, thereby decreasing the stability of the crystal. So Schottky defect will have less density, higher conductivity, less stability. Did I make it clear, guys?
Yep.
Okay. All right. Alrighty. So then there were some descriptive questions. Describe the structure of grain boundaries. Why are grain boundaries favorable sites for the nucleation and growth of precipitate? Distinguish between homogeneous, heterogeneous nucleation for the solidification of pure metal. Okay. See, for these type of a questions, what you need to do is you need to do your best. You need to write as much as you can, and if possible, draw some schematics to get the full credit. So the first thing is describe the structure of grain boundaries. So grain boundaries means what? Grain boundaries, we know that, excuse me, atoms, they will crystallize, they will merge together, grow big, then they will form grains, and then the interface will be grain boundaries. Grain boundaries are the site of atomic mismatch. They are in a higher energy state. All those things. If your answer consists of these keywords, okay, if it is consisting of these keywords, you will get full credit. Next part is, why are grain boundaries favorable sites for the nucleation and growth of precipitate? So we know that they are in a higher energy state, so they can attract these atoms, they can attract the precipitate. All those things will, if you include in your answer, you will get full credit. Distinguish between homogeneous, heterogeneous nucleation for the solidification of a pure metal. So once again, homogeneous, heterogeneous nucleation. In homogeneous, the atoms itself provide a nuclei. while in heterogeneous nucleation, a solid surface will provide nucleation surface for crystallization or solidification. If you include just these keywords, you will get full credit. But if you can draw some schematic, that'll be really wonderful. Next question, explain why hydrogen is gas at room temperature while water is a liquid. Explain by describing their electronic structure and bonding. Once again, if I know that some of the students, they have what they did is they drew the structure, just the schematic, they wrote the electronic configuration. Those things will definitely make a difference in improving, if you want to improve your grades. But however, the correct answer is, because hydrogen is a non-polar covalent molecule, okay, while water is a polar covalent compound. Water also has a strong electronegative oxygen atom that will attract the bonded electrons, will have a partial charge, will form the dipoles, and then it will form hydrogen bonding. So because of this stronger interaction that is created by this hydrogen bonding, water is liquid at room temperature while hydrogen is a gas at room temperature. So if you can write, once again, if you can write these keywords, right, like a clear explanation of, what you know about these type of problems or these type of questions, you will be entitled for full credit. Okay, next question. Yes, this question is always almost every year this I include this question, and almost many students, they really struggle with that. So solid A is very hard. It is electrical insulator in solid as well as in molten state. It is very clear and melts at extremely high temperature. Okay, what type of solid is it? So it is very clear that it is an insulator as a solid as well as in molten state. So it definitely, it cannot be ionic compound, right? Because ionic compounds are conductors in their molten state. So it cannot be an ionic compound, right? And now it says it's an insulator in solid as well as in molten state. So it cannot be metallic also, right? Because metals are conductors, metals are not insulators. So the only option left is a covalent compound. And the classical example is a diamond. For this kind of diamond is a covalent compound. This material is nothing but a diamond. Okay, so diamond is very hard. It is electrical insulator in solid as well as in molten state and melts at extremely high temperature. Right answer here was covalent. Second question was, which point defect in ionic crystal does not alter the density? We have been talking about this thing, it's a Frankel defect. And even this, the third question, give examples of each type of, I know that we talked about a different type of defects, but even if you have given just one example, I think I'm giving you full credit for that. Okay. And anyway, for section 1 and section 2, I asked specifically, guys, please, if you have time, do all of them. There would, I mean, half of the class was gone in I would say around 20% or 30% of the time was there. But many students, they did not even they never even thought about doing all of them. I don't know why. I explained in the class that do all of them. I will choose the best. Okay, so for in future also, I think I have been following this policy, and I'm willing to continue that, because see, the point of this test is to evaluate what you know, not to penalize for what you don't know. Okay, that is not my objective. I want to know what you know. Okay, so that's why I give you options. Okay, that's why I give you, because every student is different, right? Their understanding is different, the way they read their notes, or all those things are different. So students should be evaluated in a more diverse way. That's why I keep diversity in my test also. You will see that we have all the types of questions. We have the multiple choice, explain why, short answers, definitions, true and false, the short answer, this explain why type of questions, sometimes fill in the blanks. So I include everything because I have like 35 different type of students, right? But I want to give you options. I want to give you more freedom. I want to know what you know. So if there is no harm, if you have time, there is no harm in writing or attempting all the questions, and then I will see what in which one you did the best, and I will pick only those. Okay, so please keep in mind, do all of them. I know that many students, they did not do. They just left. Okay, so any questions here? Any question with the specifically with the first question here? Did I made myself very clear, guys?
Yes, sir.
Okay. Then multiple choice. Once again, I think this has been done. A neutral atom with atomic number, This right answer is D. Which description is wrong? What do you think? Which description is wrong here? I think we did these questions.
D should be
It is D.
perpendicular.
Yes. What are the advantages of Czochralski method? It has been coming straight away from the quiz. Growth of large oriented single crystals. This one also very simple. You can clearly see metal A and B, they are of similar size. Okay, even though if there is a difference in the size, it is not clear because they look almost same. So there is a possibility that it will make a substitutional solid solution, right? However, in the figure B or the sample B, the metal A is much smaller, so it will fit into the interstitial gap, interstitial site. It will make interstitial solid solution. So right answer is B. Okay, now in these reasoning and assertion problems, first one, large amount. I think we did both of these problems in class, so I'm not sure why some of the students, either they are not coming, or they're not taking notes, or they're not very careful while making notes or while attending the class. I don't know what's the reason. Both of these questions, they are coming straight from the in-class problems that we do after the end of any chapter. Large amount of undercooling does not occur during industrial casting operations. Reason is solid impurities lower the surface energy to form a stable nucleus. Yes, both the statements are true, and the reason explains the assertion. In the second question, twin boundary occurs when there is a mirror image of atom placement across the boundary. That's a true statement. Crystal structure of metals forming twin is same. That is a wrong statement. This statement is not true. For example, nitinol. Nitinol is an example of a smart or a shape memory alloy, and they form the nickel and titanium. They form twin boundaries. Okay, but that doesn't mean the crystal structure of nickel and titanium is same. It is different. The crystal structure of nickel and titanium, because they both are different metals, their crystal structure will be different. However, the atomic placement along the boundaries is mirror image. That's why it is known as a twin boundary. So assertion is a true statement, while reason statement is a wrong statement. Then you select number 4. Alrighty, I guess this might be. Let's discuss this one. Okay, for a given application, you would need to select the metal with a larger ASTM grain size number between copper. ASTM grain size number N7 given for copper, and for steel it is 4. Which one would you pick? Because the number A is, you need to select the material with the larger ASTM grain size number, so that is copper, because its N is 7, right? Now, if strength is important, which alloy would you pick and why? It's pretty obvious, because we know that N7 means what? Larger ASTM grain size number means what? It will have smaller grains. It will have more grains. More grains means what? It will have smaller grains. Smaller grains means what? Larger grain boundary area. Smaller grains, more grains, more grain boundary area. More grain boundary area means what? there are more grain boundaries. More grain boundaries means it will restrict the dislocation movement. It will restrict the slip. It will prevent the large scale deformation. So it will improve, that will improve the strength of this material. Okay, so if the strength is important, you will pick copper because it has smaller grains, it has more grain boundaries. More grain boundaries will restrict or prevent large scale deformation, thereby increasing the strength of your material. Then if used at elevated temperature, would your answer in part B will change, and why? Yes, because we know that at higher temperatures, grain boundaries become soft. At higher temperature, grain boundaries become soft, and then the grain boundaries starts to move. So if any material with the more grain boundaries, if it is that material is being used at a higher temperature, at an elevated temperature, there will be a greater extent of movement of the grain boundaries because it has more grain boundaries. So that material will become soft and leading to what to say, the softening of the metal. So you will not, so the strength will be less in that case when it is used at a higher temperature. So definitely, if you want to use any material at a higher temperature, you use mild steel because it has less grain boundaries. Does it make sense, guys?
Yep.
Alrighty.
I have a question for C
Yes.
though.
Yes.
To be more specific about the temperature, could you say something like above half the melting temperature of copper it would be? Okay.
Yes. 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 So elevated temperature means at a half of the melting temperature of any material. It doesn't matter whether it's a copper or a steel or any material. If it has been used at a half of its melting temperature, then at that point the grain boundaries will start to move. Grain boundaries will become, well, will lead to the softening of that metal, and that situation will decrease the strength of that material. Alrighty, guys, any other question?
Will these grades be posted?
Yeah, that's a good question. I haven't done. I'm still working on the grades. For the quiz, I think you will know your grades, right?
Yes, we do.
Okay, but for the test, hopefully, because I had 2 other tests for other course last week, so I had like around, along with your homework and all, I had around 150 tests to grade. So that's why it's taking a little bit longer. However, I will try my best to finish the grading by the end of the day, if not today, but most likely by tomorrow. You will see your grades. Okay, guys, any other question? We still have some time. Was this reviewing the quiz and the test, was it helpful?
Yes.
Yes. Yes.
Okay, great. I'm happy to hear that because that's the objective. I don't want to, throw a lot of material on you and then with like a superficial understanding of the of your course content. No, that's not my objective. I want to give you a reasonable amount of work, reasonable amount of content, because I have to cover most of the important topics that you need to know to understand a material science. But at the same time, my objective is to deeper the understanding. That's why I have these type of questions. I brought these reasoning and assertion type of problems because you will have an overall understanding of the concept, and then you will keep in your mind for a very long period of time. It's not just you will cram something just before the test and then the day after the test, and I don't know anything about it. So that's not the objective of this course. That's not going to work. All that you need to do is you need to be read very carefully from the notes, come and attend the class and be very attentive, and if possible, I strongly recommend, because last week just before the test, a couple of students, they were asking me what is the best strategy to work for the test. I said, if you have a book, yes, please read from the textbook, but if not, then whatever the notes has been posted on Moodle or your class notes or in-class problems, just to read from those notes very carefully. Okay. All right, guys. So if there are no questions, then we'll stop here, and then from Thursday we will start a new chapter. Your next chapter. I think we'll talk about the mechanical properties. I hope this class has mainly mechanical students. I think you guys are going to enjoy that chapter very much. Any question, guys? No? All right, then take care. I'll see you on Thursday. Bye.
Thank you.
Bye.
Thank you.